This video is going to cover real numbers and specifically perfect squares, square roots, cubes, and cube roots. So a perfect square is, if you think about a square, it's a special rectangle with all four sides are equal. A perfect square is a perfect square if you can take that many one by one unit squares and form them into a square. So obviously, one square is going to be a perfect square. If we think about four, if we take four individual squares, we can make a larger square that's 2 by 2. So 4 is a perfect square. However, when we look at 5, there is no way to put 5 squares together in order to form a bigger square. So 5 is not a perfect square. 6, even though it's an even number, notice that it gives us a rectangle but not a square. So 6 is not a perfect square. And when we look at what comes after 4, it's a 3 by 3 square, which would be 9 units. So 9 is the next perfect square. So numbers like 16, 25, and 36 are called perfect squares because you can make that square size. So a 4 by 4 grid will be 16 units. So 16 is a perfect square. A 5 by 5 square would be 25, and a 6 by 6 would be 36. Now, when a number is a perfect square, the side length of the square it forms is called its square root. So the square root of 4 is 2 because if we take 4 squares and put them together, it's a 2 by 2 square. Just like 16, the square root of 16 is 4 because 4 times 4 equals 16. The square root of 25 is 5 because 5 times 5 equals 25. And the square root of 36 is 6 because 6 times 6 equals 36. The square root of 9 is 3 because, again, we have 9 unit squares, and it's a 3 by 3 square. The side length of that square is 3. So you might want to take a second to determine whether each of the following is a perfect square. If it is a perfect square, give its square root. So pause the video and try those examples. Number 1 is no, because, again, the number 10, if we have 10 squares, we cannot put that into a perfect square, right? Even if it was 5 here and 5 there, that would be a rectangle, not a square. 16 is yes, and we have this example here. 16 would be a 4 by 4 square, so yes. And then 1 is 1 unit, so therefore it is. So the symbol of a square root, we use what's called a radical symbol, and it almost looks like a division, but it has like that V instead of the arc for division. So on your calculator, if you have your calculator, you are going to hit the second key and then the x squared key to find the square root. So if you don't have your calculator, pause the video, grab your calculator, and you can complete 1 through 6 below and check your answers. So if I have my calculator, I'm putting in second key, x squared key, 16, and enter, and I should get 4 because 4 times 4 does equal 16. The square root of 100 is 10 because 10 times 10 equals 100. And the square root of 225 is 15 because 15 times 15 equals 225. So there's the rest of the answers. Okay. So when you use a number as a factor 2 times, you're squaring that number or raising it to the second power. So you have that calculator key x squared. Those are perfect squares, right? And numbers whose square roots are integers or quotients of integers are called perfect squares. So in the table below, you can go ahead and fill out the table. Taking 1, squaring it is going to be 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So pause the video and fill in the next row with 11 through 30. Okay. Now, in the next row, -1, if we put in -1 and then square it in our calculator, if we don't put the parentheses around it, remember we talked about the parentheses in most calculators need to be there. So if you just put -1 without parentheses and square it, you're going to get a -1 as an answer, which is not correct. We want -1 times itself. So -1 times -1 is actually a +1. So therefore, we have +1, -2 squared would be +4, and so on. So just remember those parentheses when you're putting into the calculator to get the correct answer. Now, the inverse of squaring something is called the square root. So inverse is the opposite, right? So we go back, and the square root of 1 is 1, the square root of 4 is 2, and so forth. So again, to do this in our calculator, the inverse is hitting the second key and then x squared key. Now you'll notice that there's 3 different listings here. So when we just see the generic radical symbol with a number in front of it, that's referring to the principal square root. And oftentimes we're only worried about the positive value of what the square root would be. So this first column here, or row, is talking about the principal square root. But we also know that, skipping down to this last row, that when we square -2 and square it, we also get a +4, which means that -2 times -2 gives us a +4, as well as +2 times +2. So this row refers to the both values, but technically you get a positive and a negative value when you're taking the square root. And then this, notice that the negative sign is outside the radical. So what we're doing is we're taking the square root of 1, but then multiplying it by a -1. So that's how we get those negative values. Okay, so it'll depend on, are you finding a unit measure of a real life item? Then we would be doing the principal square root. If we're just finding the value of x, then we have to use this bottom row, which could be a positive or negative value for the square root. So on the next page, do the examples evaluating the radicals, paying attention to the square root of 64. That's just assuming the principal square root, and it gives you a +8, versus the -1 times the square root of 36 would give you a -6. So pause the video and try those examples. Okay, and check your work. Okay, now what I would like you to do is put in the square root of -100 in your calculator and see that you get a domain error. And this is because when we try to take the square root of a negative value, there's not a number times itself that would equal -100. Because again, squaring means, or a square root is what number times itself. So +10 times +10 would be a +100, and a -10 times a -10 would be a -100. There's no way to do a negative times a positive to get a negative answer. So in 9th grade, you'll learn that there is a way to deal with taking the square root of a negative number when you get into more complex number systems. And there's something called imaginary numbers that would take care of that. But so when we have the negative for 8th grade, we're going to say that we cannot find the value of a negative square root. Now we have solving equations. So when we have x squared equals 49, what we're going to do is the inverse. We have to get the value of x. We're going to solve the value for x. The opposite of squaring something is taking the square root. So we always take the inverse of the operation when we're solving for x, no matter what it is. So we're going to do whatever we do to one side, we're going to do to the other side. And this is where we're going to use both the positive and the negative value of 7. So there's actually 2 possible answers for this. A +7, because 7 times 7 is 49, and a -7, because -7 times -7 is also +49. In number 2, again, we want to find m. So if we take the square root of both sides, we get a positive and a -5. And you could write it just like that, where you put the both positive and negative underneath each other. Okay, now we're going to move on to finding lengths of sides of squares. So we talked about a square, and the area of a square, because the sides are all congruent, the area equals sides squared. because length and times the width are both the same. So in example 1 here, what is the side length of a square that has an area of 36 centimeters squared? So if the area equals 36 centimeters squared and we have to find a side length, if area equals side squared, we're going to do what we did above with solving the equation, take the square root of each side. Now, technically, when we take the square root of 36, we're getting two answers, a positive 6 and a negative 6. But because a side length cannot be negative, we are only going to say that the side length is 6 centimeters, not negative 6 centimeters. Okay, try to look at the rest of the page, pause the video, try those, and then check your work. Number 2, what is the best estimate for the side length of the square that has an area of 80? So 80 is not a perfect square. The perfect square next to it is 81, which the square root of 81 would be 9. So when we take the square root of 80, it's really close to 9, but it's not quite 9, so 8.9. And again, you take the square root of 80 in your calculator and see the exact value. Number 3, how much longer is the side length of square A than the side length of square B? So first I'm going to find the side length of square A by taking the square root of 100 and the square root of 49 to get the side length of B to be 7. And because this is how much longer, I'm going to subtract the 2 so that the side length of the square A is 3 centimeters longer than the side length of square B. And number 4, which of the following is the best estimate for the side length of a square that has an area of 42 inches squared? So again, if I'm approximating this, I can say, well, I know that the perfect squares above and below it, 36, the square root of 36, and the square root of 49 give me perfect squares of 6 and 7. 42 is right in the middle of those two numbers, so the halfway between 6 and 7 would be 6.5. Again, you do have calculators, so you could always do that. Now, for questions 5 through 8, I would like you to use your calculator and estimate these on the number line. Pause the video, and then we'll check your answers. So these are the answers. And notice that if I did not have my calculator, I could say, okay, the square root of 19 is between the square root of 16 and the square root of 25, which are perfect squares. So when I take the square root, I get an integer, 4 and 5. So now the square root of 19 is pretty much in the middle of 4 and 5. So 4.4, which would be a little less, right around t, right, as the best answer for that one. Now, number 9, Mr. Freeman has a farm and it has a square cornfield. It has an area of 121 square yards, the length of the cornfield. So again, I'm going to take the square root of both sides of my equation. And again, because this is actual distance, I'm going to have 11 yards, not negative 11. And then if you haven't done number 10 yet, keep the video paused, try it, and then check your answers. Okay, so notice that we have some perfect squares, 1 for our perfect squares. Then we have some that you could use your calculator to approximate, but knowing where these are located on the number line is important.